there have two objectives of this experiment. First, to investigate the functional relationship between height of fall and falling time. Second, to determine the acceleration due to gravity by studying the motion of a freely falling body.
The apparatus that are needed in this experiment is release unit, impact switch, support base, digital counter, 4 decades, mirror scale, support rods, plate holder, connecting cord, right angle clamp, and ball bearing.
So you must want to know what is the procedure, right? So without further ado, let's get into the list.
So the first step is we need to connect the digital counter with the right angle clamp using the connecting cord. After that, don't forget to set up the height using the meter scale, which is the ruler. Also, in this experiment, the height that we use for the start is 5 cm. The gate 1 and gate 2 must be connected to the impact switch using the connecting cord too. Make sure you lift up the pen every time you want to set up the height. Also, press 0 to the digital counter before you start the experiment. Put the bearing ball in the middle of right angle clamp and press start. After that, you can see the result on the digital counter. Lastly, repeat the same step every time you set up a new height for the experiment.
From this experiment, 0.05 meter until 0.50 meter was used for height of fall measure with a ruler, and the time taken was repeated 3 times to get an accurate reading. The average for the entire time taken was calculated. As you can see, height of fall is 0.05 meter, and the first trial of time taken is 0.091 second, followed by 0.088 second on the second trial and 0.090 second on the third trial, with 0.090 second for average time.
In this experiment, which is measuring gravitational acceleration, we have 5 questions in analysis. The first one, from the data, plot graph for height of fall as a function of falling time. As we can see here, the first graph height of fall versus falling time. The y-axis is height of fall and x-axis is the falling time. This graph is non-linear. Next, height of fall as a function of the square of falling time. This is the graph height of fall versus square of falling time. The graph is linear because it starts from the zero. The y-axis we put height of fall, and at x-axis we put square of falling time.
Using the height of fall as function of the square of the falling time graph, we could determine the gradient or slopes of the graph and calculate the value of g, which is the acceleration of gravity. So the formula of slope is rise over the run, which is the y variables over with x variables, and then just insert the value from the graph, and we could get the value of m, which is 6.25 meter per second per second.
For the question number 3, calculate value of uncertainty of g, which is delta g. G is stand for gravitational. Delta g equals to g standard minus g experiment. The g standard, known as 9.81 meter per second square. So, g standard 9.81 minus g experiment 6.25 equals to 3.56 m per s square.
Analysis number 4. Calculate the percent differences between the value of G calculated in part 1 above G experiment and the standard value of G standard is 9.81 meter second square. What is the percent error this experiment value. So, how to calculate the percent differences is experimental value 1 minus experimental value 2 divided by half experimental value 1 minus experiment value 2 and multiply by 100. So the calculation gonna be 6.25 minus 9081 divided by half multiplied by 6.25 minus 9081 and multiplied by 100, and the answer gonna be 200%. While the percent error we use modulus accepted value minus measured value divided by accepted value and multiplied by 100. So the calculation going to be modulus 9.81 minus 6.25 modulus divided by 9.81 multiplied by 100%, and answer gonna be 36.29%.
This is analysis number 5 from this experiment. Is there any experiment errors? Discuss. The answer is the type and number of error depends on the setup of the experiment and the measuring device that are being used. The experiment error can be minimized when the experiment conducted carefully. One of the possible errors that can be found in the experiment is systematic error in the height fallen by the ball bearing cause of using a meter ruler.
Based on the result of the experiment, the height of the fall is related to the time of fall in this experiment. If the height of the fall is increased, then the time of fall will increase as well. In this experiment, the same step has to be done 3 times for each height of fall. The reason for repeating this same step is to find the true values of the closest values to the true values. You know what I mean? The data received should be more accurate than the data obtained by repeating the same steps. Besides, the starting point should be placed at the exact location to prevent any errors in the experiment data.
The conclusion of this experiment of measuring gravitational acceleration is the functional relationship between height of fall is directly proportional to the falling time. Thus, the acceleration due to the gravity are constant. After that, the different height object does not affect the value of gravity.
Objective in this experiment is to determine the coefficient of static friction of different surfaces and to explain how forces and motions are related.
The apparatus that needed for this experiment is number 1, wooden block with rubber covered at one side. Number 2, 50-gram masses. Number 3 is 10 Newton spring scale. Number 4, string, and number 5, tabletop.
The first step is the mass of wooden block has been measured and recorded as m. While weighing, other members should set up the apparatus as shown in figure 5.2. Next, the spring scale and the wooden block has attached with a string. Horizontally place them on the tabletop. After that, the spring slowly been pulled. The spring scale's reading has been recorded once the blocks start to move. Step 4 has repeated for 3 trials, and 50-gram mass has added on the wooden block, and step 5 to 6 has repeated until the total of mass is 500 gram.
Results for experiment 2. Here are the results for the rubber surface, and here are the results for the wooden surface.
In frictional force experiment, we have 4 questions in analysis. The first one is draw and label the free body diagram of the wooden block. This is the diagram. As we can see, the upward is a normal force, the downward is gravitational force, and the backward is frictional force. The second one is plot graph of static friction force against normal force for the rubber surface and non-rubber surface. This is the first graph for the rubber surface. It is a non-linear graph, and the y-axis we put friction force, in x-axis we put normal force. The next one is the graph of static friction force against normal force for the non-rubber surface. This is the linear graph because it starts from the zero, and the y-axis we put friction force, and x-axis is normal force. Number 3, use the gradient obtained from the graph to calculate the coefficient of static friction for each surface. For the rubber surface, I use the point from the graph and not from the table. This is from the graph 2.50 minus 0.40 per 3,900 minus 500 equals to 6.18 times 10 power of negative 4. For the non-rubber surface, I use the same formula and the same technique. I use the point from the graph also, which is 2.0 minus 0.8 per 4,1900 minus 2000, which is I get 4.14 times 10 power of negative 4. The last one, compare and discuss the coefficient of static friction obtained. The value of the coefficient of static friction for the rubber surface is bigger than the value for the non-rubber surface. The rubber surface are raw and difficult to move smoothly on flat areas, while non-rubber surface are smooth and easy to move on.
So the question is, how can anti-lock brakes stop a car in a shorter distance than regular brakes? So the answer is anti-lock brakes function to stop the car in a panic attempt to prevent the collision. When they brake their car, it will not only be showing them, but holding them firmly in place. As we apply the brakes, the speed sensors track the decreasing rotation of the wheels. Next, when we use anti-lock brakes, we can reduce the wearing of brake pads and brake discs. In case of heavy braking, we can steer the car around obstacles compared to regular brakes.
Question number 2 for this experiment. From your experiment, which material has the highest coefficient of static friction? Does this agree with your hypothesis? What do you think determine the coefficient of static friction? The answer is the material that has the highest coefficient of static friction is the wooden block with rubber surface. Hypothesis is accepted because wooden block with rubber surface is rougher and have more friction towards the floor than a non-rubber surface. It is because the coefficient of friction depends on the material and roughness of the two surfaces in contact.
Question 3. Experiment frictional force. Question is, once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. First, the mass will undergo stop and go motions. This is because when the mass is being pulled, the force is actually greater than the frictional force acting on the mass, allowing the mass to move according to the pull force. Once the hand is taken off, the net force will equal to zero for a few short seconds, and then the mass will then be pulled by the spring to adjust the value of its frictional force.
Based to the result of this experiment, a rubber band surface will have a greater coefficient of static friction force than a non-rubber surface. The computation and plotted graph demonstrate that the coefficient of static friction force for a rubber surface is larger than that for a non-rubber surface, proving the prediction to be accurate. The experiment may experience a few errors. By setting the eyes perpendicular to the scale, parallel error caused by errors in reading the scale on the spring scale can be avoided. The reading on the spring scale may also be impeded by random mistake caused by the uneven surface of the table utilized. This can be prevented by measuring the spring scale numerous times and averaging the result.
So, it is better when one person pulls the blocks 3 times because the force used in this experiment while pulling the block is inconsistent. Future spring scale will need to be larger and more sensitive because some aspect of the experiment cannot be quantified. As a result, the data is more accurate and less mistaken. As conclusion, static friction will always exert more force than kinetic friction since it takes more force to move an item than kinetic friction does. Static friction only needs to sustain its force. The easiest strategy is to lessen the frictional force to move the block would be to use the rolling technique since minor frictional force was added to the diverse material, which would cause the frictional force to fluctuate